It's forced into the cylinders via the injectors just before the piston reaches the top of the compression stroke, and it enters as a finely divided or atomized spray. When these fuel droplets encounter the hot air, they start to vaporize, and after a short delay, this vapor ignites. This further increases the temperature, and the flame spreads through the fuel-air mixture. To be efficient, this combustion needs to be rapid. Since the rate depends largely on the ease with which each fuel droplet can find fresh oxygen, various designs have been produced to achieve rapid but controlled mixing of fuel and air inside the cylinder. This swirl not only supplies fresh air to each burning fuel droplet, but also helps sweep away the combustion products which tend to hinder further burning. In direct injection, or DI engines, this swirl is created by careful design of the inlet ports, which give the air a swirling motion as it's drawn into the cylinders on the induction stroke. Unfortunately, the swirl created is not very strong. To increase mixing, we have to use multi-hole injection nozzles and high-pressure injection pumps, both of which add to the cost of the engine. And because the injector is mounted directly in the cylinder head, the valve size is also limited, and this restricts the useful speed range of the engine. These limitations have so far restricted the DI engine to use in commercial vehicles. The indirect injection, or IDI engine, on the other hand, relies on passing the air at high speed from the main cylinder into a swirl chamber, or pre-chamber. This gives a high rate of swirl and allows the use of single orifice pintle nozzles with relatively low injection pressures. Large valves can be used because the injector is positioned in the pre-chamber to one side of the cylinder. This allows the IDI engine to breathe more easily and operate over a far wider speed range, the range needed for passenger cars. The IDI engine is also quieter. This is because the pintle nozzle can be designed to vary the rate of fuel injection, and so smooth out the rate of increase of combustion pressure, the source of characteristic diesel knock. Development of the IDI concept to its present level means that car drivers can now obtain diesel engines with lower cost injection equipment that provide a wide speed range and low noise levels. There are two basic designs of IDI engine. The swirl chamber is used by virtually all manufacturers. Combustion is completed in the specially shaped cavities in the piston crown. The pre-chamber is still favoured by one major European producer, and this relies on both swirl and turbulence in the throat to promote mixing while providing very low combustion noise levels. Both designs use a glow plug to preheat the combustion air to aid cold starting. The IDI engine does have one disadvantage. The combustion gases pass through the throat between the pre-chamber and the main cylinder at very high speed and high temperature, and a considerable amount of heat is lost through the throat walls. So the IDI engine is somewhat less efficient than its DI counterpart, and much research is being directed towards the development of a high-speed direct injection engine which would be satisfactory in cars. As well as providing good fuel economy, diesel cars require very little servicing. The air filters must be kept clean, as any obstruction will reduce the quantity of air entering the cylinders. In dusty conditions, the air filter should be changed more frequently. The oil and oil filter should also be changed regularly, usually at 8,000 or 10,000 kilometre intervals. The fuel filter should be replaced as specified by the engine manufacturer. Rotary pumps are self-lubricated by the fuel and should require no maintenance or adjustment throughout their working life. The modern diesel car can provide high standards of performance and economy. It meets current and proposed exhaust emission regulations in Europe without resorting to expensive catalytic systems. The initial cost is higher than for a gasoline engine because of the complex injection pump and the need for more robust components, as well as for a heavy-duty battery and starter motor. This will be offset by the lower running costs, particularly when drivers use the vehicle for a lot of short journeys. The principal elements of the diesel engine are the combustion chamber, fuel pump, injectors and filter. Together, these high-precision components ensure that the diesel is an economic, environmentally acceptable and practical alternative to the gasoline engine for vehicles of all sizes.